Hi everyone and welcome back to our wall running tutorial series. In the last episode we actually got our wall running working, but there's a few fine adjustments we want to make, as well as the ability to launch ourselves off of the wall as well. So let's jump into Unreal and take a look. So last time we managed to get our character to wall run up the wall. But a couple of things first. First of all, I want it so I can launch off the wall when I hit the jump key again. At the moment, nothing will happen when I hit the jump. Okay, and that's because we are technically in the air, so we can't jump from mid-air, and so we need to basically launch our character whenever we are wall running. So if we go to our first person character and let's find our jump inputs, which are there, and we want to keep the started and completed as they are for the most part, except for the fact that we want to check to see if we are actually currently wall running. So at the moment we want to know what we're currently doing, and at the moment our character on start wall run, we want to have a little check in there to indicate whether or not we are currently wall running. Now at the moment we have got this boolean for can wall run, and I mean that's all well and good, but that allows us to check whether or not we can wall run. But we can actually combine this and change the language of this to make it more make sense for what we actually want to achieve here. So rather than saying can wall run, I'm going to change the name of it to is wall running. Now this changes it completely from being a false here to a true, because we're going to start wall run, so I'm going to turn that on to be true. And then when I want to turn this off, we're going to go to find references. We want to turn it around the other way. So is wall running, we're going to turn off for when we landed. That's the one we just did. And here we want to invert this by doing not boolean. So now we've got a boolean which works for our jump as well. Now functionally it's no different really, we just made it flip, but by changing the language of it, it makes it a lot easier for us to apply it and make sense to us in our heads for when we want to jump. So we're going to do is wall running out, and we're going to put that in to here, and the branch on started is going to jump when wall running is false. Remember, it'll only jump if it's on the ground. Now, when it's jumping on the ground, that's not a problem. But when we're on wall running, we've got no floor beneath our feet, so therefore it won't do the normal jump. So what we have to do is actually do launch character instead. So I'm going to do launch character. And the launch velocity is actually going to change a little bit. It's going to change based upon which way we are wall running, whether we're running on the right of our character or the left of our character, because we want to run against the wall. So what I want to do is I can use the constraint that we've got on our character movement component. So I can drag out my character movement and get the constraint, get plain constraint normal, and I can put that multiplied by the strength. So let's convert that to a float. And this will be the wall launch strength. So let's say we put in 600. Put that in there. And I want it to override the Z axis. Okay, I'm going to keep the X and Y override because I still want it. Actually, no, let's keep that off. I want to keep these off because I want it to maintain the momentum of the character as they launch off of the wall. This allows the player then to do more cool tricks and jumps. So let's see how that looks to us now. So it is working, just a bit delayed for some reason. So let's take a look at that again. Okay, so the reason why we're probably seeing that is that when we got our character launching off, the problem we have is that we're still constrained. So before I do the launch, I need to unconstrain my character. So I'm going to go to character movement, set plain constraint. Well, actually, we can just do stop wall run. That would be probably a bit easier, wouldn't it? Because we've already got a function that does all that for us. That saves us a lot of work there. So let's now put that in. Try this again. get to a higher one, it'd be easier to test for a higher one. Okay, so wall 1, jump, and we can launch off our wall. Cool. Might give it a bit more power, but other than that, that's not too bad. Let's do 1200. Obviously, the values you use will depend greatly on what kind of game you want to make. There you go. Cool. That's not too bad. And what we could also do is add a little bit of height to our jump as well. So what I'm going to do on here is I'm just going to add on a Z value, and we'll do its value of let's do 350. Put that in there. And that'll just give us a little boost up as well as out. Again, get a high point, be easier to test. That's a bit better. Excellent. Okay, so the other scenario I want to be able to jump from wall to wall. So again, we have to put in a little test scenario for this. So let's put this wall here. I'm going to drag it out. Move this to the side, like so. And let's just make this a bit longer as well. I'll make these a bit taller as well, just in case we need to test the height a bit better. Okay, so we've got this little scenario here. When I jump up the wall, oh, I can't get back up. Let's fix that. There we go. I'm gonna have to make the walls a bit closer. So the jump doesn't seem that consistent. So let's work out why that be the case. Yeah, I need to bring the walls in closer. Okay, let's jump up. Cool, okay. So we can jump just fine and launch and hit the wall, but the wall isn't constraining us when we land on the other side. Oh, no, it is constraining us. So why can't I jump again? Okay, so it looks like the wall jump isn't working correctly because I'm jumping. It's launching me from one wall to the other wall just fine, as you can see, but not letting me jump from the second wall. Now, to debug this, let's take a look at how we can debug it. So I reckon we need to do a little check on the jump, because it does seem to be doing the jump. I am seeing a launch, but I think the constraint here is not correct. And we're setting that constraint on the start wall one here. So let's check what's happening here. So I think what is actually happening is that is wall running is not being checked. And the reason why is because when we turn it off, we're turning it off when we land. And that's the only time we are turning it off. So we need to tell it to turn it off when we launch the character off the wall as well. So when I launch the character, I'm going to do is wall running and turn it off. Okay, let's take a look at that now. Perfect. I'm liking that. That's not too bad. Do that again. Excellent. Okay, so to make this feel a bit more natural and a bit more in line, as you can see, when I was jumping, if I go back again and do it, jumping between the walls, I'll jump and I can pretty much keep on going. Okay, and that's because the strength of the push on the wall is it's fixed. It's set to 1200. But what if I make this value relative to how fast the character's going? So let's get the character's speed. So I'm going to get the velocity of the character, and if this will give you the direction as well as the speed the character is going, and combined into a single vector. So to get the speed out of this, we just need to do vector length. And now I can use the launch here by the vector length. And what I'm going to do is I'm going to take this and multiply it by 2. And put that in here. And same goes for this 350 over here. I'm going to just split this. And let's just try plugging the vector length straight in without having to do any extra stuff to the numbers. And let's play test that and see how that looks and behaves. So as the player jumps forward, we're getting a weird behavior where we can just do that. Okay, so I'm thinking what we need to do is make that Z override turned on. Now what Z override is going to do is basically going to zero out the Z height, so the momentum going up, and zero out and apply its own based upon the launch. Okay. Now, one thing I want to fix in that will also help this part is when you do start the wall run, we want to zero out the Z as well. So let's go to our start wall run. And I want to change the momentum of the character to have no Z momentum. So what I'm going to do is I'm going to go drag out my character movement, set velocity. And for this, I'm just going to get the velocity. Like so. And I'm going to split them both. Because I don't want the Z, I just want the X and Y. So let's put the X and Y in. That should zero out our velocity. So when we go up the wall, it should make us go dead straight rather than... That's looking a lot better. Rather than like climbing, gaining height as we are wall running. And that should solve this problem as well. Yeah, not bad. Okay, the last thing we're going to do on here is make it so that when the velocity reaches a certain threshold, we're just going to drop the character as well. So we go too slow, we're going to drop. So we're going to go over to the event graph, and we need to check our velocity all the time for this. So what I'm going to do is going to put this on our tick event. So let me just get rid of this print string. And you can do it on tick event, or you can do it on movement nodes. Either way, totally fine. We're going to go... Actually, let's do it on the movement nodes. Might as well. Because we can make use of the completed as well. So on move is like a tick event, but only when you're holding down the button. So what I'm going to do on triggered here is check the velocity and get the speed of the character from the velocity, which we know how to do. It's vector length. So vector length. And we're going to see if that's below a certain threshold. So it's less than, let's say, 200. To branch. If that's true, we can set to stop wall running. And stop wall running will just take the constraint off. So it won't do anything if we're just walking around like normal. Okay. We also probably want to make it so... Actually, no, we'll keep it like that for a second. I'm thinking we could maybe do it with completed as well. And make it so that the wall running stops when we let go of the key. But that actually might not be a good idea. Let's see how this feels. There we go. I dropped. So if I go too slow and I lose momentum, we're going to drop. Let me just do that again, but on the bigger side here. There we go. Not too bad. One more test for this. So another thing I've got an issue with is if I'm doing this and I'm jumping, it's going to try and wall run. So we're going to do another test in a second before we can wall run. Okay. So the thing I want to test now is when I hit the wall, what kind of velocity is my character doing? So again, we're going to copy our vector velocity here, and I'm going to go to my hit event, wherever I put it, there it is. And I'm just going to do a little print string at the start here to determine what value I'm getting. Now, it's a good idea to do print strings like this because it lets you figure out what values you actually want to use and what you can expect. So let's just put that in there. Oops. And push play. So if I hit the wall, you see it's not going very fast. Yeah. But it's still going to try and wall run or do the wall run check, which I don't want it to do. But if I hit the wall when I'm running, yeah, so hitting 4, 6, 7-ish. So on the event here, we're going to keep this, but I'm going to check for wall run. And part of check for wall run is looking at our velocity. So let's put in our vector length velocity and say if this is greater than 200, and do an AND Boolean. That means that both these conditions have to be true. We both have to be right at the right angle and going fast enough. If we're not going fast enough, nothing will happen. So let's test that now. If I go up against the wall, jump, not too bad. We're still getting a little bit of stickage. I'm going to call that that. And I think what we need to do for that is we want to make sure on the also for the check here is check the height of the hit and whether or not if we're off the ground or if we're currently falling. So when we check for wall, let's check to see if we're currently falling and have space to jump. So on A and here, we're going to add another pin and we're going to get our character movement is falling and put that in there. Do another test. That's a lot better. So the issue we have is when we do this, when we are up against the wall like that. And the reason why is because we are jumping up, but we then become falling very, very quickly. So as well as falling, I want to check to see how far away from the floor we are. So we're going to do a trace floor, find floor. I think find floor. The capsule location is going to be our axis location. And this is going to give us the floor result, which we can split open. And we can get the line trace. Now, part of that what you can work out is the distance of the floor, as well as whether or not we're hitting. So we can actually combine this with the falling, or replace the falling with this Boolean just fine as well. But I'm going to keep the falling in there just because it's more English and makes more sense. So I'm just going to get the floor distance and say if the floor distance is greater than, and we'll do, let's say 150. Put that in our and as well. That's the final condition. So I think the height is too high. Let's change that to 50. And it's actually print string that, so we can easily see what's going on. So just going to do a print string here and drag that floor distance all the way up here and work out what that's doing. So we're going up to 42, like that. Okay, so I'm going to go, probably not 50, we just want to say greater than 40. Get rid of my print string now. That's what I'm talking about when you use print strings, just to discover what numbers you actually want to use. See if we can do it from this height. No. Oh, bit of a plug back in. There you go. That'd be right. Classic. Okay, not too bad. It's better. And I think you just need to fine tune these numbers based upon, like again, what kind of game you're trying to make. I think that's going to be crucial. I think one thing I'd probably do in here for my own personal taste is make the launch be less strong by changing this factor of 2, something a bit lower, so 1.5 maybe. Because it felt a bit strong on the launch there. That's a bit better. Let's just make sure I can still do these double wall jumps. Cool, brilliant. So there you go. We've made our wall running a lot better. We're able to launch from the wall, and we've debugged a lot of things to make it more efficient and better to use for your game. Now, all the numbers can be adjusted based upon your own design, so feel free to play about with them and see what feels good for your kind of game. So in the next part, we're going to make it so we can determine what kind of animation or effects you want to use based upon whether you're on the left or to the right of the character. So maybe you want to put like the hand up or something like that. So we're going to do that in the next part, which you can watch right now over on patreon.com/Ryan Laley, all from just $1 a month. And you get access to all our videos early before everyone else. So once again, a massive thank you to all our Patreon members and our YouTube members for their continued support in the channel. If you're not already subscribed, make sure you hit that subscribe button, and I'll see you next time. Bye.